My name is Victoria Nsiah. This presentation was prepared as part of the HAP 709 Healthcare Databases course on Entity Relationship Diagrams taught by Professor Coffin at George Mason University's Department of Health Administration and Policy. I'm a consultant, and last year on my project supporting the Navy, our client requested a relational database to track their 10,000 plus patients for lung cancer screening purposes. We started by thinking about what would go into a lung cancer screening database. There would be patients, of course, maybe some demographic information about them, their medical history, information on their providers, maybe some appointment data would be captured. If some of these ideas align with what you are thinking, you're on the right track in thinking about the first step to creating an entity relationship diagram, or an ERD. An ERD is a graphical representation that depicts relationships between people, objects, places, and concepts. ERDs are a visual representation of how the data relates to one another and helps to organize this data. ERDs ultimately serve as a foundation to create relational databases. To build an ERD, there are three main components to be aware of. The first, entity, second, attribute, and third, relationship. Let's start with entities. Entities can be people, objects, and concepts. So back to that earlier example about the lung cancer screening database. An entity in that example could be a provider, patient, or patient history. These three tables describe the type of information that we would want captured in the database. The second component to be aware of is attribute. Attributes are properties or traits. Let's walk through some examples. For the patient entity or patient table that we talked about in the earlier slide, examples of attributes could be patient ID, first name, last name, date of birth, gender. You could even add address, zip code, state, city. Attributes are basically any type of information you would want captured for that specific entity. Attributes can be designated as primary keys or foreign keys. As you can see here under the patient table, patient ID has been designated as a primary key. Under the patient history table, history ID has been designated as the primary key. A primary key is a special relational database table column designated to uniquely identify all table records. Primary keys must contain a unique value for each row of data and cannot contain null values. You'll also notice that under the patient history table, patient ID has been designated as a foreign key. Patient ID is the primary key in the patient table. So foreign keys provide a link between the data in two tables and acts as a cross-reference between tables because it references the primary key of another table and establishes a link between them, as seen here. Because we have patient ID in the patient history table, we are able to pull that related history information by searching on patient ID for that table. The third concept to be aware of is relationships. Okay, so far we've talked about these entities as standalones, but there is more value once we can define the relationships between them. To create relationships, you have to understand the business logic to make sure that what you're doing makes sense in terms of how the entities are going to relate or interact with each other, or their cardinalities. We're going to talk about the three most common cardinalities found in ERDs. The first is a one-to-one relationship. A one-to-one relationship is when one occurrence of an entity relates to only one occurrence in another entity. For example, a patient can only have one patient history information assigned to them, and a patient history information can only be assigned to one patient, as seen here with the one-to-one relationship. Next, let's discuss a many-to-many relationship. Let's look at the example below. A provider can have one-to-many patients, and a patient can have one-to-many providers, as denoted here with the one vertical line and the crow's feet. But let's say we want to track this interaction. between a provider and a patient. That could be maybe captured in the form of an appointment. That sounds like it could be a different table. This is the case with many-to-many relationships. They tend to conceal a hidden entity. In order to resolve this, we create an association entity to bridge this gap. We'll talk about that more in the next slide. The most common way to resolve a many-to-many relationship and make it more accurate is to create two one-to-many relationships, as you can see here. A one-to-many relationship is when one occurrence in an entity relates to many occurrences in another entity. As you can see here, we took that many-to-many relationship between the provider and the patient and created that association entity now known as an appointment. So a provider can have 0 to many appointments, and a patient can have 0 to many appointments. But each appointment can pertain to one provider and one patient. You also notice here under the appointment table that the appointment ID is the primary key, but the patient ID from the patient table and the provider ID from the provider table are listed as foreign keys. Going back to my earlier story about building that database to track patients for lung cancer screening purposes, this was the end result as created in Microsoft Access. As you can see here, it can get very complicated tracking tens of entities and attributes. But when it gets down to it, an ERD allows a way to create an effective visual representation of data flow and information, and ultimately ends up serving as a great foundation to creating a relational database.